This is Mr. Hannon. Welcome to What the Format. Today we're going to go over solving by completing the square when a is equal to 1. Now, with quadratics, there's 5 ways to solve them. You can graph them, you can use the square root method or square root property, factoring, and as you saw, there's 2 types of factoring, well, 2 main types of factoring, a equals to 1, a not equal to 1, that's when you have a trinomial. Now there are other variations of that, difference of squares. Sometimes you have 4 terms and you're going to use grouping. These are all things to be aware of. That's the interesting part about algebra at some point. There are so many different possibilities on any given problem, and the variations are so infinite that you need to be aware of different methods and know when and how to use them. So that's why I qualify this. Completing the square is used in multiple ways, not just for solving. It's also used to transform a quadratic function from standard form to vertex form. And in fact, when I was in school, that's when I used completing the square. I don't remember using completing the square to solve, because you can actually, there's another method that is, in my mind, the same as completing the square, because the formula was derived by completing the square, and that's the quadratic formula. So those are your 5 ways to solve: graph, square root property or square root method, factoring, completing the square, or quadratic formula. The thing is the quadratic formula works all the time. Even if it factors, you could use the quadratic formula. So when we get to the quadratic formula, and I do a video on that, you're going to want to memorize that way, because that's the way that works all the time. So then if it happens to be factorable, great. If you can factor it, great. But see, sometimes they'll throw numbers at you, even if you know how to factor, maybe the factor pairs, just the numbers are too big. Then quadratic formula would be probably the safest and best way to go. And if the square root cancels in quadratic formula, then you know you could have factored it. Anyway, back to completing the square, a equals 1. So here's what, reminder, in standard form we have y equals ax squared plus bx plus c. We have our a, our b, our c. Well, our a is 1. So what do I do? Well, what you want to do is you want to take the b divided by 2 squared. Okay? That is what we're going to end up doing. This is the key to completing the square. Now, before we do that, we need to put a place for that, okay? So what I'm going to do is add the 3 over, okay? And that's going to give me x squared plus 24x equals 3. Make sure you leave that gap. Now I'm going to do the same thing over here. This one was moving a negative 3 over, so I added. Now this is moving a positive 7 over, so I'm going to subtract. Notice it's the same step even though the numbers have changed. And that's what I'm trying to impress upon you and hope you're seeing. The steps are what matter. When you apply a process, there's certain steps. Now, sometimes some problems skip steps. Not all the steps have applied. But if you know all the steps and know when to apply them, then the problem changing up shouldn't be an issue for you. I see a lot of students today memorizing specific problems. That doesn't help them when they get to test, because the test changes things up. And now they're lost because they memorized problems and not processes. Okay, answers don't matter. How you get the answer matters. So that was step 1. We got to move everything over. So now we want the b over 2 squared. So this is my b, remember? So 24 divided by 2 is 12. Now we're going to use that first, because what we're going to do is to do x plus 12 squared. So we want the x plus or minus the b over 2. Now why do I say plus or minus b over 2? Well, here it's a plus, and here it's a minus. So what's half of 32? 16. So we're going to write x minus 16 squared equals. Now how could I do that, Mr. Hannon? Well, because we're about to complete the square. Perfect square trinomials have a relationship. Half this number squared, if that number's there, this can factor down like this. It factors to the same factor. So x plus 12 times x plus 12 can be written as x plus 12 squared. Now I've cut that step out. Why? To save time. Once I know this is going to factor to a perfect square trinomial, I can just write the factor squared. That's one of the things you want to learn to memorize about processes, is when you can do something to save yourself some time and trouble. Now, what's 12 squared? 144. So what I need to do is add 144 there. Well, how can I just do that, Mr. Hannon? Well, you can add anything to one side of the equation as long as you do what? The same thing to the other. So we're going to add the 144 there. But that's why you wanted to leave that gap, so you could fill this in and make it your perfect square trinomial. This then factors to this. We're factoring. And if you need to do it, take 144, do your factor pairs, and see which factor pairs add to 24. You're going to get 12. 12 times 12 is 144. 12 plus 12 is 24. So x plus 12, x plus 12. Over here, we had 16. Well, what's 16 squared? 256. So that's supposed to be a 256. And again, what I do to one side, I do to the other. Okay, factors of 256 that add to 32, 16 and 16. This is where up to 25 squared you should know. Okay, you need to have those memorized. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, on up, all the way up to 25 squared. I could keep going, but hopefully what you'll do is you'll make a list and start memorizing them. Why 25 squared? Because those are the ones I see very commonly. And usually, if they really want to test you, they're going to go into the higher numbers like 256, 289, 17 squared, 324, 18 squared, 361, 19 squared. See, I just have these memorized. I don't have to do the math. That's a big part of algebra. If you're lacking on your memorization, you've got to try to catch up. So now that factored, okay? But now I got to do the math on here, so I'm now equal to 147. This is going to be equal to 249. Now be careful. You do need to do your math correctly here. If you get this number wrong, then everything else you do after that. And this may seem simple enough, but this is where sometimes students lose concentration, myself included, and make a mistake. Now, why did we do this? Well, how do we get rid of a square? We square root. What you do to one side, you do to the other. So when you take the square root of a square, the square just goes away, and now you have just the x plus 12. Now, when you take the square root in reverse PEMDAS, you need to make sure that your answer is both positive and negative. So the way we handle that is we put plus or minus, like that. Now, square root of 147. We're going to leave that. I can already see, oh, this could actually be simplified. But we will save that for another day. When I go over simplifying radicals, you could come back and see 147 is actually 49 times 3. What's the square root of 49? 7. We'll just do it since we're already here. So then we're going to get x plus 12 equals plus or minus 7 root 3. So remember, simplify means do all the math that you can. Do all the math that you can. Well, I can take the square root of 49. I can't take the square root of 3. So the square root of 49 is 7. I pull it out and I leave what I couldn't take the square root inside. Now that means you need to be able to factor and recognize multiples of perfect squares. I have that memorized. I see this a lot, so it just sticks in my head. If you're having trouble with the simplifying, just leave it unsimplified. You might lose a point with your teacher, but you should, if the teacher's giving you credit for the rest of the work, it shouldn't be too big a deal. Now what do? The opposite of plus 12 is minus 12, and then that's where we get our x equals negative 12 plus or minus 7 root 3. And that's your final answer. It may look ugly, but that's the way we leave it. Okay. Now, you could get a decimal equivalent here, 2 decimal answers. In that case, we'd use a calculator. And sometimes they're going to ask for that. But I'm trying to show you all the ways to do things without a calculator. I don't want you to be dependent on calculators. You need to learn how to think and do things yourself. Calculators are great tools, but if they're a crutch, they're bad. Now, here we go. We're going to take the square root of both sides again. Notice it's the same steps, even though different quadratic, but same steps. Okay, this is going to give us x minus 16 equals plus or minus the square root of 249. Now 249, 3 will go in there 83 times. 83, I believe, is a prime number. So no, doesn't factor to simplify, so we can just leave it. And in fact, a lot of times that's what you'll get is you can just leave it. So then what do? Instead of subtracting, over here we had a plus 12, so we minus 12. Here we have minus 16, so we add 16. Just remember it's reverse PEMDAS at this point. See, we undo the square, now we're inside the parentheses, and we undo what's inside the parentheses. We start reverse PEMDAS all over again, which means undo the addition and subtraction. And that's going to give us x equals 16 plus or minus the square root of 249. And there are 2 examples of how to solve a quadratic by completing the square. So the key steps are move your c over, okay? Well, also you need to make sure it's set equal to 0. To solve a quadratic, it needs to be set equal to 0. We move the c over. If it's a minus, we add it over. If it's a plus, we subtract it over. You leave that gap. You fill that gap in with b over 2 squared. See b over 2 squared there, and b over 2 squared there. Okay, so you take half of your b and square it. That's what fills the gap. This then factors, and that number is always half this. That sign follows down. See, a plus is a plus, Minus is minus, so half of negative 32 is negative 16. Half of 24 is 12. Once you have that, you can take the square root to get rid of this. Take the square root of both sides, that's your plus or minus, and then this simplified, this didn't. And that is how you solve by completing the square, a equal to 1. Thank you very much for watching. It's been Mr. Hanna with What the Format. Happy mathing.